balance with reactive process. So in this process, we will look into how to solve mass balance using extent of reaction. Okay, so we are going to do one simple example of how to use extent of reaction to solve mass balance. Okay, right, we have a question here. A feed to a reactor consists of 100 mole per second nitrogen, 300 mole per second hydrogen, and 1 mole per second argon. Fractional conversion of H2 of hydrogen is 0.6. So the question wants you to calculate the extent of reaction and calculate the outlet flow rates from the process. So the equation, the stoichiometric equation of the process is given where you have nitrogen mixed with hydrogen producing ammonia. Okay, so this is the stoichiometric equation of this process. So before we go further into the questions, let's imagine like this. Okay, let's draw the process flow diagram of this process. So this is direction. So basically you have a reactor. Okay, so in the reactor, so what goes into the reactor? So you have nitrogen, 100 mole nitrogen, and you have 300 mole per second of hydrogen, and you have 1 mole per second of argon. Okay, you see, hydrogen produce ammonia. There is no argon here. So argon is, in this case, argon is inert compound. So normally if inert compound will come here. Okay, there will be inert here. Right? So the question wants you to find the outlet flow rates. Outlet flow rates for the process. Of course, if this process, so you expect to have ammonia, right? Because you produce ammonia. Okay, what else will exist here? Since it says fractional conversion of hydrogen is 0.6, so you will have fractional conversion of you will have unreacted hydrogen. So definitely you will still have hydrogen, and also you will have nitrogen. Okay? So let's label it like this. So we have N here, So this 0.4 will come out from this reactor here. Okay? Yeah, so what we'll do is we find this one first. H2 not converted equivalent to 0.4 times with the feed of hydrogen that goes into the process. So you have 120 mole per second is not being converted. Okay, so this is 120 mole per second because it's not being used, so it will come out through the process. So how much is being used? So actually 0.6 from 300 is 180 mole. Okay, 180 mole is being used for this process. So the question wants you to find now extent of reaction. Remember, if we're using the method of extent of reaction, so we have to write the equation for each compound in the equation. Right, let's do this. So the first compound, we will look into first compound and two, what will be the equation for extent of reaction, and 2 here, out, right? This is out. So I did not O because it means out. Out equivalent to and 2 in minus, because only one coefficient extent of reaction, right? So let's do now for hydrogen, and hydrogen out is equivalent to and hydrogen in. Hydrogen is also a reactant, so it's going to have 3 minus, because coefficient is 3 extent of reaction. And then let's go for NH3. NH3 out is equivalent to NH3 in plus, because it's a product, and then coefficient times by extent of reaction. So how are we going to find extent of reaction, and how are we going to find outlet of flow rates? Once we get the extent of reaction, we can easily find the outlet flow rates here. Okay, since we already know this, right? We already know this information from the fractional conversion. So we know here, this is 120 mole per second is equivalent to how much mole that goes here? Wrong place. Okay, sorry guys, sorry. This is not for nitrogen. This answer just now is for hydrogen. Wait, okay, sorry. Sorry for the limited resources. Okay, now, sorry guys, let's continue. Okay, this is actually NH2O. Okay, so we know this based on fractional conversion of hydrogen 0.6 just now. Okay, so we substitute this value 100 mole per second, equivalent to how many moles that goes in? Was 300 mole, right? 300 mole per second minus 3 extent of reaction. Okay. You complete this equation, then you get extent of reaction equivalent to 60 mole per second. So this process actually occur with the extent of reaction as 60 mole per second. Okay? So now 60 mole per second. So you get your extent of reaction already. So now we need to get your outlet nitrogen 40 mole per second. So you get your answer here. So your answer for nitrogen is 40 mole per second. That is not being used. Okay. So what will be your product now? Okay, your product. So still using the extent of reaction that you already got just now. So you know, do we have nitrogen in? Do we have feed for nitrogen in this process? No, we do not have feed for nitrogen because nitrogen is a product. So we know this one is actually 0. 0 plus 2 times by 60. So NH3 here is actually 120 mole per second. 120 mole per second. Right. And for argon, it does not involve in the reaction. So its value is still 1 mole per second. So this is how you use extent of reaction to obtain your flow rate of your product. Okay, the first thing is what you have to do. You have to determine your extent of reaction, and it can be obtained if you have enough information to start your calculation. So I hope you understand how to use this extent of reaction, but don't worry, we will do some tutorials to get ourselves familiarized with